So one way to sort of jumpstart or enable the comfort with mortality, one way to take away the sting of mortality is to get into ambiguity. Ambiguity, two things can be true at once. We encounter a paradox, we don't need to solve it. Paradoxes are not problems to be solved, they're questions to grow into. And Death Salience presents us fundamentally with a paradox that our life is simultaneously meaningless because it is short and urgent because it is short. That's paradoxical, and there's no solution to that. There's no correct answer, there's no right answer. It's a problem to grow into. Our lives lose meaning because we'll be forgotten, but the meaning of life is not just to be remembered. Life is meaningful when you're in relationship, when you're doing work that matters to you, even though it doesn't matter in the long scale. Ambiguity. Um, my first love is physics. When I was 13, I was a physics prodigy, and like, lucky for me, nobody ever noticed that. And so I was never nurtured into math and physics the way I could have been. And I count myself very fortunate. Most of what I ever knew about physics, I've forgotten. It's like a weird dream that I had that I can no longer really remember very clearly. And I'm grateful for that because all of the space math and stuff, it was occupying the areas of my brain that would normally be occupied by relationships. And if I were still that physics prodigy, I couldn't be with you. I'd be alone. I'd be alone in the space math and not with other people. But I keep up with like new discoveries and what's going on out there and cosmology, at least to the extent that I can track it. So my starting point with people is often scale. So let's go. Here we are. We're at the middle scale. We call it the middle scale because it's where we live. But in infinity, there's no center, right? Infinity has no middle. Anywhere you go is equally the middle because there are no boundaries by which to define the center. So we call this space that we live in the middle scale. But every time we look for something smaller, we can find it. What does that mean? It means in 1700, people thought the smallest thing in the universe was sand because that was the smallest thing they could see. But then we start getting magnifying glasses and then microscopes, and we can see that sand is made up of pockets of minerals that are separate. And you can break those apart. You can then see dust. And then with microscopes, you can see that dust has texture, it's made of something. Eventually, with a lot of really creative math and measurement, weights and masses, things like that, we discover atomic elements. There are what, 116 or so? Don't quote me on that. Atomic elements. Uh, I've forgotten. I'm glad to have forgotten. Don't remind me. Um, and everything in the universe is made up of just combinations of those elements. Those elements are atoms. Right? The atom, until just about 1900, was the smallest thing in the universe. It was a thing that could not be divided. It could also not be seen. Too small, but now we can see atoms. And they're made of something. Atoms are made of protons, neutrons, and electrons. In fact, an atom isn't a thing at all. That's kind of weird because we look around the universe and we see solid things, but there really are no solid things. There's mostly empty space actually. An atom, the nucleus of an atom, the protons and the neutrons are really far away from that orbiting shell of electrons. The electrons are like at planetary distances at scale, you know? If the nucleus was the size of the sun, then the first protons would be like around Venus or something. The first electrons would be around Venus or something. And they're not. They're super tiny, but still, there's nothing really there. There's nothing really there. And then when you look at that nucleus, there's nothing there. It's a point in space, and it's made of other things that are also just points in space. They don't occupy any space. They don't have any breadth or width or depth. Right? Those protons and those neutrons are also made of smaller things. Those smaller things are called quarks. Quarks, muons, and so forth, leptons. What's down under that scale? I don't know, something. And then maybe when you dig down underneath that, you find other so-called elementary particles, the particles that make up everything else. But we keep having to revise what an elementary particle means because we keep finding something smaller. Maybe there's the brain, not brain like in your head. Brain is in short for membrane, and that's the apparently three-dimensional space we occupy. That's more like 9 or 11 dimensional, and most of those dimensions are very, very tiny. They don't like extend in more directions. They're very, very small. They contain gravity, and there's something vibrating from a different dimension that would appear as little coils, little rings of energy that vibrate at different frequencies that make the leptons, that make the atoms, that make the molecules, that make the bodies. But every time you look for a smaller thing, you find it. Does that mean we're gigantic? One American stereotype is that people go to college and they smoke marijuana and they imagine that um, the whole world is like one atom, and it's part of a bowling ball that some giant is rolling down a bowling lane, something like that. Could that be true, or are we actually very tiny? Well, every time we look for a bigger thing, we find it. Meaning that we used to think the Earth was the universe. There's a sky, it's bigger than the Earth, but it's part of the Earth, it's part of the world system. And the sun is part of the sky, it's in the sky, which is part of the world. And then we start doing some elementary measuring, parallax lines and shadows and stuff like that. And we realize the sun must be really far away. So there's a bigger system out there, bigger than the world. But the world's all that's really important, and everything goes around the world. It isn't until um, fairly recently, 1700s, that we figure out the best explanation is the world and the other planets we know about at the time orbit the sun. But we still kind of think to some degree that the rest of the universe is static, it's unmoving, it's unchanging. And then with the discover of parallax, we start to see things are further away than we imagined. And some of them are moving and changing. Supernovae show us that things are changing, and then um, pulsars kind of give us a way to measure how big the universe actually really is. By the time we'd realized, by the time we'd realized that everything in the universe is flying apart from everything else at close to the speed of light, well, you compute everything's flying apart from everything else, and then you imagine that process in reverse, and you come up with an infinite crunch. So we imagine that the universe started as an infinitely small singularity that exploded and made everything. That is still exploding and making everything. The Big Bang is now, right? Some people like to disbelieve in the Big Bang, but it's not an ancient event. It is an event that's ongoing. We're in the middle of the middle of the Big Bang. All right, so the solar system isn't the biggest thing. We used to think The galaxy, the Milky Way galaxy, was the biggest thing because we could look up and see stars and know that they were like our sun. But then you look a little deeper and you see that some of those stars aren't stars at all. They're their own galaxies, like incomprehensibly far away. And then you start counting stars and galaxies, you realize there's about a couple 100 million stars in the Milky Way, and we've counted at least half a billion galaxies at this point, each with an average of 100 or 200 billion stars. If you do the math and get to that Big Bang point, then you know that the universe is right around sloppily 14 billion years old. And so it can't be more than 14 billion light years side to side, as in the old Monty Python song. That's false because yes, nothing can travel faster than light, but space is being created. The Big Bang is ongoing, and space is being created between stars and galaxies at an ever increasing rate. Well, how's that? Well, if there's a meter between you and me, and a billionth of a meter gets created between you and me, that's not enough to notice. But what if there are a billion meters between this uh, asteroid and that asteroid? Well, then there a meter is created in between those, and the numbers that we're dealing with are so large that we're just creating millions of light years all the time between things. So the best math I've seen has the universe at more like on the order of 92 billion light years side to side, and we can only see 14 billion light years of that because of speed of light limitations. So most of the universe has dropped away from what's visible. Every time we look for a bigger thing, we find it. Are there bigger things than galaxies? Yeah. There seem to have been like gravitic filaments in the early universe that caused things to clump. You know, why have galaxies, stars, planets, you and me? Because there were these gravitic filaments that made some things just pull together in some places more than others. And when that process gets started, it only takes a tiny little variation in the background gravity to make that happen. And then you get all the things that we can see. And then you see these uh, galaxy clusters, right? Some structure that underlies gravity, underlies galaxy formation, so that there are more galaxies in one place than another. And you look behind that and you see bigger things yet. We call this the middle scale because it's where we are. And we can only see a certain distance up and down in scale, but that scale appears to be infinite. And as our tools keep improving, we can imagine larger and smaller things. And paradoxically, those are kind of the same. Like the universe would be maybe just one of many, many universes. There's no reason to presume that the universe we live in and can see and interact with is the only one. Multiverse theory, popular for a while, it's the idea that our universe is just one bubble that's expanding. It's on this brain, and it's one bubble growing on that brain, but it would be surrounded by a sea of bubbles, a foam, a cosmic foam of universes coming into existence and growing and expanding and then dissipating back against the brain. And those microfilaments, those energetic loops of energy, would also be vibrating against that brain. Not really falsifiable. You know, for me, not that interesting a question because there would be no way to attempt to disprove it at this time. But some fun speculation. So that's the beginning of ambiguity. For me, that's often the conversation that I would have with people, the beginning of ambiguity. Once you can start to understand that the things you think are there aren't really there, they're mostly empty space. It's useful to think of them as solid surfaces, but you never touch them, right? The electromagnetic resistance between you and the thing you're trying to touch prevents you from touching. And what you're touching is that wall of resistance. If you could touch it, then you'd merge with it like pieces of metal cold welding in space. Or worse, fuse with it and create nuclear explosions. You can start to when you can start to think in those terms, you can start to hold opposite ideas in your head. Right? Paul Tillich, belief, faith is belief in the presence of doubt. So one reads their holy text and reads the creation story and believes it because it adds meaning to their life. Maybe it just adds poetry to their life, but they believe it. And then they learn evolutionary biology, and those two ideas are incompatible, but biology is so well founded. When you understand it, you almost have to believe it. And then you have these two incompatible ideas. Which do you hold to be true? Well, Tillich would say there's a way to hold both to be true. There are good reasons to doubt the creation stories in religion, but we retain them maybe because they have meaning. And then we have to sit with that paradox. Both things can't be true. This is clearly the false one, but the meaningful one. And so I'm going to accept this. And this, those are opposite. How do you, but it's not a thing that needs to be solved. It's a question to be grown into.